In the sweeping, grand narrative of the Second World War, history rightly celebrates the brilliance of the commanders, the courage of the pilots, and the intellectual breakthroughs of the scientists. We speak of the men who directed armies, the men who flew into fire, and the men who broke the uncrackable codes. But the true, grinding reality of total war was won or lost far from the marble halls of command, down in the mud, the grease, and the dirt of the operational airfields. This is the story of one such man, a figure largely absent from the official histories, a hero whose genius lay not in calculus or combat, but in the humble, vital art of keeping things running. He wasn't a pilot, destined for the glory of a dogfight and the camaraderie of the squadron mess hall. He wasn't a commander, mapping out global strategy with colored pins. He certainly wasn't a scientist, working in sterile laboratories on radar or nuclear fission. He was a mechanic, a master sergeant, perhaps, or a chief petty officer, a man whose life was measured in torque settings, oil changes, and the sweet, powerful roar of a fully operational engine. Opening shot. Rural airfield, a mechanic wiping grease from his hands. This man, let us call him the chief, for his rank was secondary to his authority in the repair bays, had no formal engineering education. His knowledge came not from textbooks at Cambridge or MIT, but from a lifelong, intuitive communion with machinery. He learned by dismantling, by troubleshooting, by listening to the subtle cough of a failing carburetor or the dangerous wobble of a damaged control surface. He possessed the rare, practical genius of understanding why things failed and how to make them whole again, often with nothing more than his bare hands and a rusty spanner. And yet, in the middle of the most complex technological war ever fought, this quiet genius, working amidst the noise and filth of a frontline repair hangar, would pull off something extraordinary. It was an act of ingenuity so profound that it did not merely repair a plane, it tipped the local balance of power. Using nothing but scrap metal, salvaged parts, and an intuition that bordered on the revolutionary, he managed to outsmart the might of the Luftwaffe itself. He was the ultimate battlefield improviser, the man who knew that a war fought with machines is ultimately won by the men who can keep those machines flying when the textbook says they are finished. His greatest weapon was not a gun, but a welding torch and an absolutely uncompromising will to survive. His story is the perfect embodiment of the maxim, necessity is the mother of invention. And in his corner of the war, necessity was a daily, deadly, and immediate master. The chief and his maintenance unit were stationed at a forward operating base. Let's imagine it as a crucial airfield in the Mediterranean or perhaps the North African theater, a contested slice of dirt and concrete whose fate was essential to controlling the supply lines. His squadron was in deep, agonizing trouble. The reason was simple and brutal: attrition. The Luftwaffe, specifically the dedicated German fighter units assigned to the area, attacked almost daily. These were not random, ineffectual raids, they were calculated strikes designed to cripple the Allied air forces on the ground. The Germans targeted the runways, the fuel dumps, and, most critically, the hangars and maintenance facilities. The cycle of destruction was relentless. Allied aircraft were being destroyed faster than they could be replaced. A fighter lost in combat was one thing. A fighter destroyed on the ground by cannon fire, just sitting in its dispersal bay, was a morale-crushing waste. The rate of loss was unsustainable, leading to a critical shortage of operational aircraft. But the losses didn't stop with the airframes. The base was suffering from a crippling scarcity of spare parts. The long, vulnerable supply lines, stretching across oceans, through submarine-infested waters, and over hostile territory, were frequently cut, bombed, or delayed. Crate after crate of necessary engine cowlings, delicate instruments, hydraulic fluid pumps, and, most frequently, simply rubber tires, never arrived. The situation was dire. The operational pilots, exhausted from constant flying and the psychological strain of watching their friends crash, were ready to go. They had the training, the courage, and the fuel. But they didn't have the planes. With supply lines cut and the enemy growing stronger, constantly pressing their technological advantage, the base was on the brink of collapse. The balance of power in the sky above that crucial theater was tipping dangerously in favor of the Axis. The ground crews were becoming desperate, scavenging parts from one wreck only to see that cobbled-together plane shot down the next day. The High Command's response was simple, but impossible to fulfill: hold the line. More parts are coming. But the chief knew the truth of the materiel war. The needed parts were weeks, maybe months away, if they ever arrived at all. Pilots needed planes. Planes needed repairs. And all the chief had was junk. The maintenance yard had become a morbid, depressing graveyard of twisted aluminium, burnt-out engines, and shredded rubber, a silent testament to the efficacy of the German strikes. To the conventional mind, this wreckage was waste. To the chief, standing amidst the grime, the heat, and the overwhelming smell of burnt fuel and desperation, this was his arsenal. He knew that to survive, they couldn't wait for supply ships, they had to build their salvation from the ashes of their failures. He looked not at what the wreckage was, but at what it could be. The time for conventional repair was over. The time for radical, backyard, scrap metal engineering had begun. In the blistering North African sun, or beneath the damp, corrosive air of the Mediterranean coast, the graveyard of shattered aluminum stretched out behind the maintenance hangar. This was the base's scrap yard, a monument to the German Luftwaffe's efficiency, a mountain of unusable wreckage, twisted and mangled beyond any conventional hope of salvage. To the quartermasters, it was a liability, useless tonnage cluttering the perimeter. To the pilots, it was a depressing reminder of losses. But to the chief, wiping the corrosive salt and oil from his goggles, this mountain of misery was the raw material for survival. While others saw scrap metal, he saw possibilities. He saw alloys that could be repurposed, shapes that could be reformed, and systems that could be cannibalized, not to replace broken parts with identical ones, but to create entirely new solutions. He began a meticulous, tireless campaign of collection. He walked through the detritus with the focus of an archaeologist, his eyes trained on the properties of the material, not its original function. He collected bent propeller blades. Their high-grade aluminum, twisted in the impact, was still perfectly strong enough to be flattened, cut, and hammered into robust sheeting. Burst fuel lines. The copper or steel tubing, once carefully straightened and cleaned, could be bent into auxiliary hydraulic conduits or simple engine injectors. Shredded fuselage panels. The large, slightly curved sections could be reformed into replacement air scoops or cooling vents. Shattered engines. Even the cracked engine block held treasures, bolts of a specific thread, internal gears of hardened steel, and wiring insulation that could be salvaged. Crucially, he also scavenged the wreckage of downed German aircraft that had crashed near the perimeter. These were often superior in metallurgy and design to the Allied aircraft of the time. The chief viewed a ruined Messerschmitt or Junkers not as a trophy, but as a high-quality parts catalog, a source of hardened steel and specialized alloys the Allied supply chain simply couldn't deliver. Once his hull was complete, the chief essentially disappeared into the workshop for hours, sometimes days, at a time. The workshop was a ramshackle building, lit by bare bulbs, filled with the clang of hammering metal and the hiss of the welding torch. His small crew of devoted mechanics, who understood his unconventional genius, formed a cordon, running simple errands but otherwise leaving him to his almost alchemical processes. His superiors, the base commander and the logistics officers, were bewildered. They saw him spending precious man-hours on what appeared to be wasting time, straightening bent metal, filing oddly shaped components, and fusing together disparate parts into confusing, non-standard assemblies. They demanded accountability, insisting he focus on official repair manuals and sanctioned protocols. "Chief," the exasperated supply officer might have asked, "why are you welding a piece of a German radio antenna to the cowling of a Spitfire?" They didn't realize they were interrupting an act of genius improvisation. They didn't realize he was building something the German Luftwaffe had never anticipated. An unconventional fighter squadron, equipped with machines that were not merely repaired, but fundamentally re-engineered to better survive the specific, brutal conditions of the siege. The chief was fighting the logistical war with the tools of a blacksmith and the mind of a rogue design engineer. His creations were not pretty, but they were about to become terrifyingly effective. The period of intense, solitary work finally ended with the breakthrough, not a single grand invention, but a series of integrated, improvised upgrades applied to the battered, semi-functional aircraft that remained in the squadron. The chief hadn't tried to perfectly replicate the original parts, that was impossible. Instead, he had sought to improve the aircraft's performance and survivability using the only materials available, scrap. The modifications he introduced were practical, robust, and often drew upon his deep, intuitive understanding of fluid dynamics and metallurgy. Airflow adjustments, the scavenged cowling. He observed that the standard air scoops on the aircraft were prone to damage and allowed too much dust into the engine in the sandy environment. He used salvaged, hardened aluminum panels, some even stripped from a crashed Heinkel bomber for its superior alloy, to fashion replacement cowlings and carburetor scoops. These new scoops had simpler, wider, and more resilient intake ports, dramatically reducing engine wear from grit and slightly improving the laminar flow of air over the engine block. Engine patch-ups, the welded manifold for the damaged exhaust manifolds, critical components that often failed under stress. He didn't have the specialized heat-resistant alloys. He simply welded patches onto the failed sections using salvaged high-strength steel from German landing gear struts. These rough, patched manifolds weren't perfect, but they held the high-temperature gases long enough for the engine to complete its mission, dramatically extending the life of units that should have been scrapped. Reinforced control surfaces, the hinges of war. Many planes were rendered unflyable by damage to the hinges and actuators of ailerons and rudders. The Chief used heavy-duty, custom-filed steel from tank track components, scavenged from a nearby maintenance depot, to create over-engineered, robust replacement hinges. These additions were heavy, but they made the control surfaces virtually immune to flutter and far more resistant to light flak and small arms fire. The decisive modification: the makeshift cooling system. One modification in particular, however, changed everything. It was the solution to the eternal problem of the early Allied fighters in that climate: overheating. The Chief recognized that the Allied liquid-cooled engines, designed for the cooler climate of Northern Europe, struggled desperately in the relentless heat and thin air of the desert. He needed more radiator surface area, but he had no new radiators. His solution was a radical piece of battlefield engineering. He took sections of the aluminum wing skin from a salvaged, non-operational Allied bomber, metal known for its excellent heat dissipation properties. He then meticulously cut and welded this sheeting into a series of auxiliary cooling fins and ducts that he strategically mounted inside the engine bay and along the outer fuselage, where the airflow was highest. But the most ingenious part was the heat transfer system. He ran thin copper tubing, salvaged from burst fuel lines, carrying heated engine coolant through these new scrap metal fins, turning the fuselage sections into a vast, improvised secondary radiator system. This copper was likely salvaged from the wreckage of the very enemy planes that caused the damage, making the modification a profound act of poetic justice. The results were astonishing. Suddenly, the squadron's oldest, slowest, nearly retired aircraft, planes that were perpetually grounded due to overheating issues or structural fatigue, were resurrected. These rough-looking planes, heavy with their scrap metal additions, began to exhibit surprising new traits. Climb higher. With the massive cooling issue mitigated, the pilots could now push the engines harder and sustain power for longer, allowing them to climb higher and achieve better performance at altitude. Fly longer. The stabilized temperature meant the engines were no longer burning themselves out, dramatically extending the lifespan and operational endurance of the aircraft. Survive hit after hit. The reinforced control surfaces and patchwork of high-strength alloys meant the planes could absorb more damage and still limp home, confounding the German pilots who were used to seeing their targets explode or fall apart easily. The squadron pilots, initially skeptical of the rough, Frankenstein-like appearance of their planes, were gathering around the modified aircraft. They felt the difference immediately. The engine held steady, the controls felt taut, and the plane seemed to possess a newfound ruggedness. The junk planes were no longer junk. They were battlefield-optimized machines, forged in desperation and ingenuity, and they were ready to take on the might of the Luftwaffe on entirely new terms. The operational readiness rate of the base began to soar, and the Germans were about to face a very unpleasant surprise. The air above the besieged base had long been a hunting ground for the German Luftwaffe. The pattern was predictable. A flight of superior German fighters would sweep in, catch the weary Allied pilots in their struggling, overheating planes, and pick them off with ruthless efficiency. The Allied base was a known quantity, a soft, attritional target. But the day the Chief's re-engineered squadron finally took to the air against a major enemy raid, that pattern was shattered. The German pilots, likely flying advanced aircraft like the Messerschmitt Bf 109G or a formidable Focke-Wulf Fw 190, executed their standard attack approach. They expected easy targets. Sluggish Allied planes barely able to climb out of the desert heat, ready to be dispatched with a quick burst of cannon fire. Dogfight reenactment. Enemy pilots confused. Instead, they encountered something entirely unexpected, something profoundly confusing. The engagement began, and the Allied planes, the patched-up veterans that should have been struggling, began to perform far beyond their known limits. The climb rate. The German pilots' initial attack dives were met by Allied fighters that, instead of laboriously clawing for altitude, were climbing sharper and faster than the German intelligence reports, and the Germans' own experience, had ever suggested was possible. The scrap metal cooling systems allowed the Allied pilots to push their engines to maximum power for sustained periods without the telltale signs of overheating, giving them the vital vertical maneuverability they needed to escape the initial ambush. The endurance. The battle dragged on. Usually, after 20 minutes of high-G maneuvering, the Allied engines would begin to protest, forcing the pilots to break off and descend. But these planes kept fighting. The scrap metal engine patches and salvaged oil lines held firm. The German pilots, flying sophisticated, but often maintenance-intensive aircraft, were suddenly finding their own fuel and temperature gauges hitting critical limits while the crudely modified Allied planes kept flying and fighting. The resilience. When the Allied fighters did take hits, which they inevitably did, the impact was less decisive. The heavy, non-standard steel reinforcements the chief had crafted from tank parts and high-grade German wreckage absorbed rounds that would have sheared off control surfaces or crippled an engine on an unmodified plane. The Allied planes were battered, but they were not broken. They were limping home instead of falling in flames. The post-action reports filed by the bewildered German pilots told a story of genuine alarm and confusion. They described engagements with unidentifiable upgraded fighters, flying with unexpected tenacity and climbing in ways they didn't believe possible for those specific Allied models. Their initial operational analysis led them to only one rational conclusion: the Allies must have received massive, immediate reinforcements. They suspected new models. Secret Allied technology rushed to the front line. Perhaps a stripped-down, lightweight variant of an advanced fighter, or maybe a clandestine arrival of high-performance Spitfires or late-model Mustangs that their intelligence had missed. The German commanders began reporting the presence of a Phantom Squadron, aircraft that exhibited the speed and performance of new designs but retained the familiar silhouette of the older, weaker Allied planes. The truth, of course, was infinitely more modest, yet strategically devastating to the German command's intelligence confidence. It was one man, working alone, with a simple welding torch and a mountain of scrap metal. The chief hadn't invented a new fighter, he had simply perfected the old ones for the environment they were in. He had used battlefield ingenuity to nullify the German technological advantage in that specific theater. The Luftwaffe was fighting not just a squadron of pilots, but the concentrated, practical genius of a single mechanic who had turned their own debris against them. The psychological effect of this unexplainable superiority was immediate. German morale began to suffer, and their previously confident daily raids became hesitant, cautious, and less effective. The tide, locally, was already beginning to turn, not through official deployment, but through sheer grit and grease. The immediate consequence of the chief's breakthrough was the survival of the squadron. The sudden surge in operational readiness and the fighters' newfound tenacity allowed the Allied pilots to hold the line. They were able to inflict critical losses on the surprised Luftwaffe units, forcing them to divert resources and scale back their damaging daily raids. The chief's scrap metal re-engineering saved dozens of pilots, brave men who would have otherwise been shot down in underperforming aircraft, and preserved critical air superiority, turning the tide in their sector. The operational base, once on the brink of collapse, became a hardened, self-sustaining thorn in the German side. Eventually, the chief's heroic improvisation bought enough time for the High Command's official plans to materialize. Reinforcements did finally arrive. Fresh squadrons, brand new aircraft, and the fully supplied spare parts that were so desperately needed months earlier. When the new aircraft landed, immaculate and factory fresh, they were impressive, but the veterans of the Phantom Squadron looked at the rough-hewn, patched-up planes of the chief with deep, abiding reverence. Despite his immense contribution, the chief's story, as is often the case with the greatest unsung heroes of wartime logistics, never appeared in the headlines. His name remained in the dusty maintenance logs, known only to the men who flew and worked on his creations. His incredible inventions, the scrap metal cooling ducts, the salvaged control hinges, the welded engine manifolds, were never patented. When the new supply lines were fully established, his bespoke, battlefield solutions were gently removed and replaced with standard, approved factory parts. The military prefers standardization, not genius improvisation. Yet, his legacy endured far beyond the official paperwork. Among the crews he saved, he was, and remains, a legend. The stories of the grasshopper that wouldn't die, and the fighter that could climb like a rocket, were passed down through the ranks. He was revered as the genius mechanic who outsmarted the mighty Luftwaffe with nothing more than creativity, courage, and the war's forgotten leftovers. His achievement was a powerful testament to the unsung value of improvisation in conflict. The Allied war machine was eventually powered by industrial might, but in moments of crisis, it was saved by human ingenuity, by the mechanic who saw the potential in twisted metal, the pilot who flew a rescue mission into an impossible field, and the code breaker who found a pattern in random noise. The plane the chief re-engineered may now sit in a museum, restored to its original factory finish, scrubbed clean of the grease, the patches, and the welded scrap metal innovations. But the true story of its survival remains written in the invisible history of the squadron, a proud, enduring chapter dedicated to the man who knew that in the brutal war of attrition, junk wasn't a liability, it was an opportunity. His quiet triumph demonstrated that the ability to fix and innovate, even under the most extreme pressure, is a form of genius as vital as any grand strategy or scientific discovery. He found salvation in the wreckage, proving that the greatest advantage of all is the resourceful human mind.